Hi and welcome to Design Patterns in Modern C++. I'm Umar and today I'm going to discuss the Singleton design pattern. This pattern is used when you want your class to have only one instance. But why would you want your class to have only one instance? One reason could be you might have an application class that manages the state of your application. And obviously, there should be only one instance of this class that will manage the state of the entire application. Let's see the intent of this pattern. The intent is ensure a class only has one instance and provide a global point of access to it. If you want your class to have only one instance, then ensure that it is accessible globally. This is the structure of the pattern. There's a class called Singleton and it has some data. And this class should have only one instance. So we create a unique instance of this class, and that unique instance is given to the clients through this static instance method. Note that if clients call this method multiple times, this method will always return the same instance. And then there are some other operations that this class contains. Now the example that I'm going to use is of a logger class. This class is used by applications to log messages into a file. And obviously, there should be only one instance of this class throughout the application. If multiple instances of this class are created, then the log file may get corrupted. So we will ensure that when clients create instance of this class, they will always get the same instance every time. Let's switch to Visual Studio and see how this class can be implemented as a singleton. So here I'm in Visual Studio. I will create a project and I'll call this logger, and I will add a class logger. So the first thing I'll do is add a file pointer so that I can write the log messages into the file. And then add another member. This will represent the tag that you want to attach to the message. And then I will add this method called log. This will accept a string. This will be the message that the clients will write into the log file. And then I will add one more method called setTag. Here I will pass the string by value and then move it into the member function m_tag. Now I want this class to have only one instance. So the first thing I should do is prevent the users from creating multiple instances. And for that, I will make the constructor private. And I will also need a destructor here. Let me synthesize the functions. So I will first implement the constructor. Here, I will open the file. If the file could not be opened, then the stream pointer will be null. So I will throw an exception here. In the destructor, I will close the file. And in log, I will simply write the message into the file. So I will use fprintf. This will be the tag. And this will be the message. And to ensure that the messages are immediately written into the log file, I will flush the stream. In setTag, I will simply assign the tag, but I will move this value from this tag into m_tag. Let's implement main. Now I cannot create instance of the logger. Even if I do, the compiler will not allow it because the constructor is private. So I need to provide a way through which the clients get the instance of this class. So I will create a static instance of the logger here. And this instance will be given to the clients through this static function called getInstance. Now I cannot use the C++17 inline keyword here. It will not work. Instead, I will have to initialize this in the usual way outside the class. This should be if not string. Now the clients can get the instance through this function. Let's build and run. Cannot initialize here, so I need to remove the uniform initialization syntax. Let's build again. And it works. But there is no output on the screen. Instead, I will open the folder where the file is created. Let's open it up in Notepad, and you can see the messages. So everything seems to be working fine, but there is a problem with this implementation. I will create a function here. Let's say this is some function called init. And here I create instance of the logger, or rather get the instance from the logger, and then log this message, initializing, and invoke init here. And you can see the application has crashed. Can you guess the reason for crash? The reason for crash is a copy is created here and here, because these objects are not references, these are concrete objects. So when a copy of the object is created, at the end of the scope, it is destroyed and it closes the file. And in this function, when this instance tries to access the file is already closed. So that's why I will use references here. Now this should work fine. Let's open the log file, and here it is. But we have to ensure that the user does not create a copy of the logger instance. That is why when you implement a singleton in C++, you have to also implement the non-copyable idiom. In non-copyable idiom, you will prevent the user from creating copies of the object. And we can do this very easily by using the delete specifier on the constructor, that is the copy constructor, and the assignment operator. Now the user will not be able to create copies of the instance. So if I remove this reference operator, the code will not compile. So this is one way of implementing the singleton design pattern in C++. And in this case, the instance is created before main is called. So that's why this is called as the eager instance or eager instantiation. But there is another way to create the instance, and that is called lazy instantiation. In that, the instance is created on the heap in the getInstance method itself. So let's see how to use lazy instantiation. Here I'll create a pointer instead of a concrete object, and this can be initialized in the class itself, but I have to ensure that I use C++17 standard. And here I can create the instance like this. But I don't want the instance to be created every time when getInstance is invoked. That's why I will perform a check here. Now this instance will be created only when getInstance is invoked. Now before I run the code, I want to show you something. I want to log the call to the constructor and the destructor. Now let's build. And you can see the call to the constructor, but there is no call to the destructor. And this means the instance is not deleted. We know that when new is used in C++, you have to call delete because new and delete must be used as a pair. Now what to do here? How to call delete on this instance? Do you think we can call delete at the end of the main? It may not be possible because the logger may be used by a global or a static object. And that object may be still around after main returns and it might use your logger instance. So that's why you cannot delete the logger instance at the end of the main. But is it really necessary to call delete on the logger instance? Because even if it leaks, there is no problem because it has to be around as long as the application is running and it must be destroyed only when the application terminates. So there is no need to call delete on it. This type of singleton is called leaky singleton. But there is one thing that you have to keep in mind. If your destructor is releasing any resources, then they will not get released because the destructor will not get invoked. So for example, if you're releasing a mutex in the destructor and other applications are waiting on that mutex, then it will not get released. So that's why in such cases, you have to ensure that you call delete on this instance because the destructor must be executed. Now there are different ways of taking care of this issue, but the easiest one is using the standard C++ function @exit. With @exit, you can register a callback function that will get automatically invoked after main returns. And in that function, you can call delete on the logger pointer. Now it requires a callback. Instead of creating a separate function and then passing its address here, I can use a lambda expression. That's it. Let's build and run. And you can see the destructor has been invoked. This means the instance is properly destroyed. So this is how you can implement the lazy instantiation in C++ by creating the object on the heap. But there is another way, and that is very efficient and very easy to implement, and that is called Mayor's Singleton. In Mayor's Singleton, all we have to do is create a static instance of the logger inside getInstance function. This code is no longer required. Now this instance will be created only when getInstance is invoked. So this instance is a lazy instance. You no longer have to create a member variable of the instance pointer here. Even this @exit is not required. Let's build and run. And you get the same result. So this instance is created only when getInstance is invoked. If you never invoke getInstance, the instance is never created. And this is a much better approach as compared to this one, where we create the instance on the heap, because then you have to deal with the deallocation of this pointer. So these are the different ways through which we can implement the singleton design pattern in C++. And there are other alternatives as well. This was a basic implementation of the singleton design pattern in modern C++. Thanks for watching. I'll see you in the next video. Goodbye.